G'day, welcome to Edington Machine Works. My name's Adam. Today I'm going to show you how to cut a straight line on the equator from the centre without moving the y-axis. So this is what we've got to do. We've got a cutter that's 3mm radius, and we've got to calculate the angle for the step over. The straight line will be on the equator, but the cutter will be offset without moving the table on the y-axis. So, as you can see with the 3mm cutter radius, that gives us an r sine x degrees of 3mm, which, rearrange the formula, gives us a sine x degrees of 3mm over the radius. X degrees equals the inverse sine of 3mm over the radius. To translate that into reality, we've got a dog clutch here. This part is on the equator, but the cutter has to be cutter radius south of the equator. Same with the matching part. Come on, there we go. And it fits in nicely. This is for a winch gear on my trike. So, we have the centre of the rotary table zeroed on the 150 mark, which gives us a current radius of 16mm. Now I've done the coordinates, done the calculations there. There and there. Because we have a 3mm cutter radius, that gives us the ability to go for a 0.5mm step over without affecting it too much. So we've got our zero focus. We've got our zero in line with the y-axis, which gives us our 90 at the equator, but we have to cut this at 30 degrees. So here's our zero. The angle has to be 30 degrees, but the offset is 10 degrees 48 minutes. So there's our 10 degrees, focus. There's our 10 degrees. And as you see here, it falls on the 4-degree mark. And we would need to come 48 minutes. There's 40. There's 50. And there's 48. Lock our rotary up, and that gives us where to cut, focus, to take that part out. It's going to be loud soon. Okay, next one, unlock. Here's our 30-degree mark. We want 10 minutes 48 seconds, 10 hours, 10 degrees 48 minutes. So there's our 10 degrees. Which lands on the 30 there. We want, there's 30 minutes, is 40 minutes. Is 48. Lock her up. Going to be loud soon. And as you can see there, we've got a nice step over for each coordinate, and we've got the line on the equator without moving the y-axis. Hope you enjoy. For a larger cutter radius, you have to be aware of the difference between the tangent point and the centre line of the radius. That difference. That will be on the sine mark of that radius. And here's the fit. And I can't feel any slop in that. It comes off just nicely. It'll slide nicely on the spline. Hope you got something out.